Okay, so I got cut off there last time with the last one. So carbon dioxide is a greenhouse gas as well, and some people have suggested that carbon dioxide has an impact on our climate when volcanic eruptions occur. And that's true, it does, but it does not account for our current greenhouse warming that we have. It's the CO2 from volcanoes is only a portion of that CO2. Anyways, when that pressure builds up, that pressure can, if it can escape, you'll have more passive eruptions. If it can't escape, it tends to have more explosive eruptions. So felsic materials tend to have more explosive eruptions, and mafic materials tend to have more passive eruptions. So when these gases go up into the atmosphere, they have an impact on our surroundings. For example, when light comes in, it will hit those gases and reflect right back into space. Therefore, it will cool off down below. And it's kind of like sometimes people call it a nuclear winter, but it's also what we call a volcanic winter. Right, so the ashes up there, the ash and the gases can actually cause it so that the heat cannot come in, cooling down the planet. Now, also, if you have a lot of particulate matter in the atmosphere, it tends to actually refract more light, causing it to have a reddish hue to it, or a yellowish hue. It's often, if you've ever had a forest fire or something like that in your neck of the woods, the sky turns red. If you guys know anything about art history, this one is called the Scream. This happened right after Tambora erupted back in the late 1800s. And when that happened, a lot of the night sky around the world turned to this kind of reddish color. And this is Edward Munch was the artist for this. And he actually was walking along the boardwalk walk. I can't say it today. In Denmark, if I remember right. And he remember looking up in the night sky and said that it was blood red, and he just felt so foreboding inside that he wanted to scream. And so he painted this picture of the Scream, which is a famous painting that we've probably all seen before. So it's kind of interesting that volcanoes actually have an impact on other things. It has an impact on culture. It's had an impact on art. It's had an impact on literature. The Tambora happened at the same time in the 1800s as when Frankenstein and Dracula was written. What was actually happening during this time, the authors, Mary Shelley, if I remember right, was actually in a contest to see who could actually make the scariest story because of how gloomy it was outside, how dark it was outside because of all the ash that was in the atmosphere. And so she came up with Frankenstein, and one of the other authors came up with Count Dracula, which is kind of cool that that volcanoes can actually impact cultures and economics around the world and things like that when they actually erupt. Other things they can actually cause extinctions. If you have temperature changes too fast, you can actually have local extinctions, and if it's global, you can even have global extinctions. Some of our biggest extinctions in the world in our geological past have been linked to large volcanic eruptions. And so that's something to think about. Okay? It can have global cooling, but it also can have global warming to effect. Because if you have tons of CO2 out in the atmosphere, it can actually have warming as after effects. So usually what happens is that's cooling for a couple of years, and then it has warming for a couple more for years after that as the CO2 is more in the atmosphere. So when you have dramatic changes in climate because of volcanic eruption, we have quick cooling, quick heating, back to quick cooling again. Lots of organisms don't like that, and therefore it's something they've had extinctions because of it. So other things that come out of volcanoes are lavas. And by the way, you can, when you go to the slides, you can click on these, and they'll take you to some videos of what these two kinds of lava look like. There's two types. We have one that's called a'a and one that's called pahoehoe. A'a is they're both Hawaiian words. A'a is this crumbly stuff, and it moves slower, often because it's cooler. They could have come out of the same vent. Like, for example, in this picture, they came out of the same exact vent, but this lava flow cooled off sooner, so it's all crumbly, and as it moves, it breaks off as it goes along. Whereas this one was hotter for some reason, and therefore it flowed a little bit more like taffy, right? So you can see the ropey texture of it, what we call pahoehoe. So the a'a is the jagged stuff. Pahoehoe is not nice and smooth. And one way I can remember it is, let's say you were walking across this lava flow like a Hawaiian might would in the olden days, and and he had to get across this, and he didn't have proper shoes on. He'd walk across this part here, and he would say, ah, 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 because it hurts so bad, right? And whereas the poor hoy hoy would be nice and smooth, it would be easier to walk across. I know it's a stupid, cheesy way of remembering it, but remember that the ah, ah tends to be jagged and moves slower, therefore cooler, and therefore the hoy hoy is this kind of rolls off your tongue and has this more smooth material, like taffy. So the last thing that comes out of a volcano is what we call pyroclastics. Now, pyroclastics can be really big angular blocks, or streamlined blocks. Some of these streamlined blocks we call volcanic bombs. You can see some examples of two here. I have one right here. This one actually came from a mountain outside of the Grand Canyon called Mount Trumbull. This guy here is basically what it is the lava was shot out of the volcano, and as it came down, it started to cool, and then formed into this little raindrop shape. Now, what's more likely is that there was probably a ledge, and the lava was falling off the ledge into these bulbs and falling down to form these here. They can form in either way, but the more common way is the taffy just falling down like that. So this is a volcanic bomb. And, or you can have a volcanic, when they're all composed together, we might get what we call a volcanic breccia. So this is a good example up here of a volcanic breccia. Now, this I love. This is one of my favorite words, and part of the reason it's my favorite word, this is actually the longest word in the English dictionary. Let me try to see if I can say it real quick. It's pneumomono-ultramicroscopic silica volcanosis, okay? Which basically means it's a disease having to do with the lungs that has really small particles of silica that is from volcanic origin, and it's that disease caused by that dust. So it's basically from breathing in dust. This is what you're basically breathing in. It's glass shards. You're breathing it in. So that's not good for you in the first place. But silica, if you remember, has this capacity to it. The mineral silica has a capacity where it soaks up moisture. So lots of times people put ash in like cement. And when they put that ash in the cement, it actually makes the cement harden faster because the silica will actually bring in the moisture. Remember when you buy like maybe like a wallet or a purse or even beef jerky or whatever, or maybe your cell phone, and in that cell phone there's this little packet that says silica beads or silica gel, do not eat. Right? And the reason you don't want to eat it is because it's pure silica, and that silica actually can be dangerous because it will actually dry you out from the insides. Well, that's what volcanic ash basically does. When you breathe it in, it actually absorbs into your lungs, drying out your lungs and clogging your lungs so you can't breathe. So it basically makes you suffocate from the inside out. Terrible way to die. This video here is a great video, and I highly recommend it. This is actually a video of Mount St. Helens after it erupted. A reporter got caught in the eruptive cloud. And he got out, but you could tell when he breathes there, he can barely breathe because he's breathing in all this ash, and his eyes hurt because all of the ash is in his eyes, it's scratching his eyes. And what he referred to it as hell on earth, because he thought he was going to die for one thing. It was so dark because the ash cloud was overhead, blocking out the sunlight. It's a terrible kind of there's lahars, which is volcanic mud flows that were going through the area. Ash all over the place. It gives you kind of a hint of what it might have been like to be in a volcanic eruption. I highly recommend it. To go click on the link and actually watch it. I can't watch it in here because of the capabilities of the software. But you can go watch it by going on the links. Okay. Now this ash sometimes can go in all over the world. Though when Mount St. Helens hit, I actually was alive here near Yellowstone, small town called Rexburg, Idaho, when Mount St. Helens erupted. And I remember this very clearly, where later that Sunday, it erupted on a Sunday morning, but later that Sunday afternoon and the next day, we had ash falling down on our cars. And I'd walk out, and there was this film of white ash, kind of like a dusting of snow in a sense. And we were all over our cars. I even have some ash samples, and I leave it in our lab here so people can see it. But that ash went all over this neck of the woods. That was a small eruption, though. But remember, Mount St. Helens was only 1 cubic kilometer, so it didn't go as that far, but it still had a huge impact on the region. If Yellowstone were to blow, the last time Yellowstone blew, it had significant amounts of ash all the way down to Texas and Louisiana. And we do have some evidence of it in here in North Carolina, but it's such minuscule accumulations of it that it's really not that much. But this area is where you had large accumulations of it. This is actually a deposit here in Nebraska, right here, where they had almost 6 feet of ash from a volcanic eruption as well that killed off a bunch of rhinos and horses during the prior to the last ice age, right? And it cut off a lot of organisms here, killing them, and there's a big fossil beds of them all over in that area. This is an example of that same volcanic eruption that I talked to you about in Pinatubo. The ash was all over the place, and that's the #1 cause of death in that volcanic eruption. They actually mitigated it fairly well and got people out, but the ash deposited on all these homes, and quickly after there was actually what you would call a hurricane, what they call a typhoon, coming through the area, soaking the roofs, which is, remember, just put volcanic ash on top of it, basically cement, buried people alive because they have collapsed buildings. That was the #1 cause of death in Pinatubo, from collapsed buildings because of the wet ash. And when this rains down, all this particulate can actually move down and form what we call lahars, which are very dangerous features. I'll talk about those more later. So when you have a volcano, there's really basically 3 types of volcanoes that we talk about. We talk about what we call shield volcanoes, composite volcanoes, or cinder volcanoes. Now, shield volcanoes are usually what we call mafic volcanoes. They're from mafic magmas that are just a bunch of lava flows. Okay, so it's this gentle slope of lava flows coming out from one central point. So that lava comes out, flows away, and as it does, it forms this nice little big broad shape, or what we call a shield, kind of like a Roman shield on its side. Right? These things can get very big, and a good example of this one might be the Hawaiian volcanoes of Kilauea, or shield volcanoes. Okay. However, you can get what we call composite volcanoes, which is these guys are more mafic. These are more intermediate to felsic, so they're the thicker magma. So as the magma comes up, they'll cool off right there at the vent, and then they'll break through and cool off the vent, break through, cool off the vent, and so they'll form these really steep-sided mountains that we call stratovolcanoes or composite cones. Now, every once in a while, though, you might have an ash eruption, so the ash might fall out, fall back down on the side of the mountain. So you have these layers of both lava flows and ash. So we call them composite volcanoes. These guys tend to be felsic in nature, whereas cinder cones and ash cones are purely pyroclastics, the materials that come out during the pyroclastic. So these guys can be mafic or intermediate, but they tend to not be felsic. So now I'll show you an example of a graph for this later that kind of helps you understand and tie all these together. But let me give you some examples of these. So here's some different sizes of these different things. Okay, so here's the shield volcanoes are the largest. They tend to be very, very big. Where stratocones tend to be a lot smaller. They're steeper though. Shield volcanoes are a lot larger, but stratovolcanoes are steeper. Now, there are other features that can actually form inside of them. You can have complex volcanoes where there's multiple vents. You can have multiple cones, or you can have what we call a caldera erupt, where you have the magma chamber actually collapse. So this magma chamber right here might collapse, and when it does, it forms this big ring, which is what we call a caldera, and then other volcanoes might come up in it. So this is an example of actually Mount Vesuvius, or you might think of it as Pompeii, the location which Vesuvius destroyed, right? It's a stratovolcano as well. There's other features like we call pyroclastic cones, and these guys are a lot smaller. These are sizes of a couple kilometers in width, in diameter, and a couple kilometers high. Whereas these pyroclastic cones are only a couple 100 feet high or so. So they're a lot smaller. So here's an example of a shield cone. This one's actually one from near where I grew up, outside of Idaho. We can this nice broad shield volcano with the vents right here, and you can see this broad material going out. These are usually mafic materials and tend to form where you have mafic magmas. Well, if you have mafic magmas, that means the places where the lava came up and didn't cool off to form into felsic materials. And we'll talk more about that when we talk about plate tectonics. So plate tectonics and the type of volcano you have is directly correlated, and we'll talk more about that in our next unit as we go. Some of the biggest shield volcanoes in the world happen to be shield volcanoes. The biggest one on our planet is the tallest mountain in the world is actually Hawaii, which is a shield volcano. When I say tallest, that means from the bottom of the ocean to the top. The only top portion of that volcano is actually exposed. That's why we don't think of it often as the tallest mountain. We usually think of Mount Everest as the tallest mountain, but Hawaii actually is taller.